This question, we've been told that two particles A and B of masses 3 and m are each attached to two ends of a light inextensible string which passes over a smooth pulley P. The two particles are held at rest, both at a height of 1.28 meters above horizontal floor, with the portions of the string not in contact with the pulley being vertical. Okay, so let's just get a diagram of this situation. It does for now look like a standard pulley question, so we'll start with our default diagram. Here's my two particles. I can call them A and B. Each of them have weight, so those are the downwards forces we have here. Each of them have tension or a generating tension in the string. And here's the distance from the ground. So now I want to have a quick think about which direction things are going to move. So now I just want to think about when we release this system from rest, what direction are they going to move? Which is heavier, A or B, 3G or mg? As we keep on reading, we're told that the system of two particles is then released from rest, and B is the one which accelerates towards the floor, and it accelerates at 1.96 meters per second squared. Okay, let's add that to the diagram. So here's the direction of motion. This is the direction each of these particles are going to be moving. Part A tasks us with finding the tension in the string for the period before B reaches the floor. So it's just how we would usually find the tension in the string. So I'm going to do a motion equation for particle A. So that's F equals ma. The resultant force is T minus 3g, and that equals 3a. I know that the acceleration is 1.96. In this system, with connected particles, both particles have the same acceleration, the same velocity for all the time while the system is intact. So this is going to be 3 times 1.96. I can just do some rearranging here to find an answer or a value for t, and we get 35.3 newtons. In part B of the question, we're asked to determine the value of m. Well, now that we have the tension, let's find a motion equation for B, and then we should be able to solve for m. The resultant force on B is going to be mg minus t, and that's going to equal mass times acceleration. Okay, once again we can do some rearranging. I'm going to factorize here to make m the subject. I haven't even touched my calculator yet. All of this rearranging lets me know what to put into the calculator. My value for t divided by g minus 1.96. All into the calculator. That gets me 4.5 kilograms. That is the mass of particle B. Just a quick sense check. That would make it the heavier of the two, and that verifies why B was the one going towards the ground, while A was the one moving up. Part C of the question asks us to find the speed with which B strikes the floor. So here we're going to make use of some Suvat equations. Let's first collect our variables. The displacement is 1.28. It started from rest. We're looking for the velocity it hits the ground with, the final velocity. We know the acceleration is 1.96, and we do not know the time. With the variables we have, and looking for v, we're going to use v squared equals u squared plus 2as. Substitute in everything that we have, and we get v equals 2.24 meters per second. That's the velocity that B hits the ground with. Since the system is connected and intact all the way up until that point, that's also the velocity that A is moving with. The next part of the question tells us that when B reaches the ground, when B reaches the floor, it remains at rest. We're asked to determine the greatest height above the floor reached by A. Okay, so A is on the move. It started 1.28 meters above the ground. It traveled another 1.28 meters. This was at the same time that B was traveling down by 1.28 meters. And then the system broke. From then, A was just moving by itself, moving freely under gravity. We're going to collect Suvat variables from that very instant, and we're going to decide, and we're going to calculate just how much further A is going to travel. So, our Suvat variables, we're looking for the displacement, that's unknown. The initial velocity is the same 2.24. that we found in part C. The acceleration is now negative 9.8, and we do not know the time it takes. We're using v squared equals u squared plus 2as again, and we're going to substitute in, rearrange for s, and then we'll grab our calculators. So s is going to equal 0.256 meters. So from the moment that the system breaks, particle A travels an additional 0.256 meters. Before the system broke, particle A, how high was it above the ground? It was 2 times the 1.28. It was 2.56 meters above the ground. If we add these together, the 2.56 and the 0.256, we get the total height above the ground, the total distance from the floor, 2.816 meters.